Assalamu alaikum, guys. This is Muhammad Jashuddin. Welcome to the GFC School, guys. Today we will discuss E equal to MC squared. Guys, we have to put this. And here, M mass, C is velocity of light, velocity of light, okay, and E here total energy, okay, energy, guys. So from this equation we could see mass, energy, and velocity is light, the velocity of light. That means we need an object, and here kinetic energy, the total energy. That means here kinetic energy and potential energy. So we have to take an object, and all from where we get the kinetic energy from the motion of the object, guys. So if we apply force F on an object, and if the object moves, then we will get kinetic energy. Moreover, we have done a work, guys. Look, a force we have done. This is the constant force. Very actually this constant for ds distance. Okay, for very small, very tiny distance, this is constant force which we applied. Guys, now due to the force, the body will get, the object will get motion. Okay, guys, due to the motion, there is created kinetic energy, and kinetic energy means all work done. Okay, difference of kinetic energy is work done, guys. Work done. What do you mean by work done? What do you mean by kinetic energy, guys? Since we applied force F, and it has happened very tiny displacement ds. That's why you could say F ds. This is actually work done, and work done means difference of kinetic energy. Guys, this is the kinetic energy, and this limit is 0 to s, because here distance or displacement is F ds. We've got this formula, and we can say kinetic energy. Okay, this is okay. Now guys, Newton's second law, and what you know from the Newton's second law, F equal to dmv upon dt. Guys, this is the Newton's second law formula, because change of momentum due to time, and we can write like this way. Okay, we got the force F, and in this equation we can put it, guys. That means E equal to dmv upon dt. Now limit of integration will be mv, okay, not s, guys, because here is changing momentum due to time now, and ds, okay, here ds. Again, guys, we know what you know. We know very simple equation. From the very basic, we could handle this direction, guys. ds dt equal to p. So in the equation 2, we could put this. That means, let me delete here. Okay. That means kinetic energy equal to integration mv dmv dsdt means v. Guys, this is our record line, and from this line what can we see? We can see differentiation, derivative mv. That is PV formula we could use. Look, here 0 mv, dv means dv plus v dm. We can differentiate this as well. Okay, integration 0 mv. Now mv dv plus v squared dm. This is another line. কে আসছো লাগাই দাও Okay, guys, just now we got velocity v ds up in dt. Nice. And we put this here, and we got this line, and derivative mv. Derivative mv, that means uv formula in differentiation dv plus b derivative dm multiplied by simple. That means this is equation 3. Okay, guys, from the relativistic formula of mass, we know m equal to m naught 1 minus v squared upon c squared root. Guys, this is actually mass of the object. Mass of the object. Okay, in motion. Okay, in motion, and it is mass of the object, mass of the object at rest. Okay, and here c is light velocity, velocity of light, velocity of light. Okay, and b here, velocity of the object, velocity of the object. Nice. From this formula, what can we say? What can we write? From this formula, here, cross multiplication root 1 minus v squared c squared. Okay, and m naught. We could do square. Okay, that means like this way, squared. So m squared 1 minus v squared c squared bracket equal to m naught squared. Okay, here m squared c squared minus. Okay, let me do another line. V squared c squared. Okay, m naught squared. Now we do cross multiplication. M squared c squared minus v squared m naught squared c squared. Okay, yes, this line we got. Okay, now multiply m squared c squared minus m squared v squared equal to m naught squared c squared. Like this. After completing this, I will come to class. Okay. Now, m square c square minus m square v square equal to m naught squared c squared. Yeah, we do differentiation. Okay, we can do differentiation. How can do this differentiation, guys? Here, 2m dm c squared minus m squared 2v dv plus v squared 2m dm to 0. These are constant. All are constant. Okay. Now 2m dm c squared minus m squared 2m squared v dv plus minus v squared to v squared m dm to dt. Now we can divide both sides by 2m. That means what can we get? 2 to m. Okay, c squared dm minus mb dv minus v squared dm. This is okay. Now we could write, what can we write? mb c squared minus v squared dm equal to mb dv. This mb dv we can put, actually where is that line? Okay, then that line was mb dv. Okay, our record line was actually in the second portion, that was 0 m c squared minus here v squared dm plus mb dv. We had this line, alright? We had this line, and mb dv equal to c squared minus v squared dm. We can put here from this line. That means here actually m naught v squared dm, this equal to this plus c squared dm minus v squared dm. Okay, that means this cancel. Look, we got this kinetic energy equal to integration m naught c squared dm. Finally, we've got this. A great line has become this small line. Okay, nice. Now, what can it be now? Very simple, you know. So, this integration, guys. Now I'm doing integration. Okay, and this line, try to understand. This line I produced at first. Okay, and in this line I put the value of mb dv equal to this. Okay, and by putting this, we have done some calculation. This cancelled each other. Okay, finally we get c squared dm, and now our variable is dm. That's why our integration limit is not lower limit and upper limit m. Now we can do integration. What is that integration? Here dm, c here constant. That's why we have to bring outside of the integration, and it is actually limit integration. Okay, dm. When you see this dm, we can write m. This is the formula of integration, and here higher value m and lower value m naught c squared. That means from the formula of integration we know c squared m minus m naught. Okay, minus sign from the formula. That means mc squared minus m naught c squared. Guys, okay, what is that? We've got mc squared minus m naught c squared. That is EQ. This is actually still kinetic energy. At first I said about kinetic energy from the definition of work, and work means change of kinetic energy. At first I said, if you recall, then you can get the point. Can be equal to if ds. Okay, this from this line, step by step, we've got this line. So we have to remember each step for deducting this formula. Okay, that means our starting line was this, and from this line through various steps we've got steam. Okay, w, and we've got m c squared minus m naught. And from this, we have to understand what is this, what is this, what is this. At first, I said this is kinetic energy, and since we are not mass of the body at rest, that means is the kinetic energy of the object when it was rest, and mc squared here total energy, and it here kinetic energy. That means what can we say, guys? What can we say? Direction is very long. That's why for understanding we have to think more. Anyway, from this line, try to look at this line and try to understand. Here, ek plus m naught c squared, we can write like this way. Okay, like this way we can write mc squared equal to ek plus m naught c squared. Oh, guys, we have to know what is this. This is the mass of the object at rest. That means, what can we say? What can we say? We can say, actually, this is a kinetic energy. Kinetic energy, okay. And this is potential energy. Potential energy. That means total energy. That means we can say what can we say? This is total energy. We can say total energy equal to mc squared. Okay. Look, yeah, m naught c squared is the energy of the object at rest, and here is the energy of the object in motion. That means, what can we conclude? We can conclude very easily, simply. If you understand the basic of the kinetic energy, potential energy, then work, energy, power chapter, and actually dynamic chapter, then we can conclude this. But for deducing this total energy to the mc squared, we have to use the relativistic mass of the object. That then I used this formula. Okay, m naught 1 minus b squared c squared. This formula I used for which reason? Because it's a relativistic mass, and Einstein said the mass will be changed in the motion. That's what I used this formula. And yeah, you could see this is the rest mass, this is the mass of the object in motion. And I have to do here differentiation. Okay, after doing the differentiation, I got something, and then I put in the integration term, and I got finally this section. And this section means kinetic energy. And I don't know, this m naught means here actually potential energy or energy of the object at rest. Okay, and first I said this is the kinetic energy. What do you mean energy? Energy means total energy. And what do you mean by total energy? Kinetic energy plus potential energy. That means finally you have got this. So we can say total energy E equal to mc squared. This formula Einstein said, and this is the very renowned and popular and very famous formula. Most of person discuss about this, but they don't know how it has come. Just now I have shown this way. For knowing this direction, you have to know just basic, work basic, kinetic energy basic, and velocity basic, and oh gosh, little second law formula. Okay, and from that formula, I got something by doing the differentiation. So you have to know the differentiation. Okay, and you have to have the concept of relativistic mass. That I said this, and from this formula we did differentiation, and through differentiation we got upward, and we plus here. Finally got this, and here we have done integration. Because why I have integration here? We have to calculate the total energy, and for getting the total something, we have to do summation, and summation means integration. Okay, why finally say I have done integration for getting the total amount, total for doing the summation for that means addition. Small amount of energy, a lot of small amount of energy will get the total energy, and such way. Finally, I got equal to M system. Guys, again I say here M is the mass of the object. Okay, and C is the velocity of light. C is the velocity of light, and M is the mass of the object. Mass of the object, and E is the total kinetic energy. Energy. Okay, energy, guys. That means we can convert any object into energy by this formula. Just we have to know the velocity of light and mass. If you can think any type of object and try to convert that object into energy, just you use this formula and put the value of mass of that object and velocity of light, then you get how much amount of energy you have produced from that object, just using this formula. And for understanding formula, what I have said and what I've written just now, what I've done just now, is just okay. Okay, guys, thanks a lot. Assalamu alaikum.